let's have a recap on the basic ideas of sketching polynomials. You remember we did look at this earlier in the year when we were looking at just functions in general. But when we're drawing a polynomial, well, the y-intercept is the constant, just like the linear function, y equals mx plus b. B was the constant, and it was the y-intercept. In the quadratic, ax squared plus bx plus c, c was the x-intercept. In any polynomial, it has to be, because of course the y-intercept is when you sub in x equals 0. And so all the terms with x disappear, and you're left with the constant. So if I've got some function like this I want to draw, I don't need to expand the whole thing out. Of course, to work out the constant, that would be a waste of time. I just look at the constants in each of them. So I've got 1 times minus 1 cubed times 2 squared, which gives me... That's right, minus 4. Okay, so we can plot that one in. Now, we know the x-intercepts are the roots of the... I'll get it the right way around. Roots of the equation, 0 of the polynomial. So it's already factorised for us, so that makes life a bit easier. The x-intercepts are... Yeah. Minus 1. The next one would be 1. And the next one would be minus 2. Okay. Now, where to start and finish our polynomial? The leading term in a polynomial will always what we call dominate. So as x gets bigger, it's the leading term that really tells us about the function. So all we really need to know is where the leading term starts and finishes, because obviously that will be the biggest value out of infinity and minus infinity. And wherever that starts and finishes, that's where this polynomial will too. So our leading term will be, again, we don't have to expand the whole thing out. We just look at the leading term of each bit. We've got x times x cubed times x squared, which is x to the power of 6. So if I was to ask you to draw x to the power of 6, we would get, well, we wouldn't get a parabola. X squared is the only parabola, but yet we would get a U shape. Yeah. Remember, higher the power, steeper at the sides, flatter at the base. Only the quadratic is a parabola. So, all right, x to the power of 6, and we know we'll start up here, finish up here. Okay. Now look at the individual roots. They will behave like the factors. So a double root will look like a parabola, or it'll just touch the x-axis. Or in fact, any even one will have that U sort of shape as it touches. Now we've got an even one there, x plus 2 squared. That would be a double root at negative 2. So I know it's going to just touch there. So I've got a U shape. But the other thing I know is it starts up here. So I also know which way around it's going to turn. It must come down and go up. So, okay, at that point we know it does that sort of thing. Odd powers, other than the power of 1, because power of 1 would look like a straight line. It would just cut straight through. But other than that, it would inflect like our classic cubic over there would have that sort of shape as it goes through. So on our one, we've got a single root at negative 1, so we know it's just going to cut through negative 1. But then I've got a triple root at positive 1, so it will inflect. So I know over here at 1, it's going to do that sort of shape. There we go. There's the actual graph. Isn't that lovely? And if you wanted to locate that turning point exactly, now that we know calculus, we could, of course, go and differentiate the curve and locate stationary points and do things like that. If you can factorise a polynomial completely, then it's just going to be a basic curve that's been shifted. Just remember, function x minus a would be shifting to the left or the right, depending on whether a is positive or negative. So if you had x minus 2 squared, for instance, we know it's our basic parabola shifted to the right 2 units. Okay, let's have a look at this one. X minus 1 to the 4, x plus 1 cubed, x plus 2 squared, x minus 2. There it is. Let's just confirm all the different features that we just looked at there. The first thing we said was the y-intercept. In this one, it would be minus 1 to the power of 4 times 1 cubed times 2 squared times negative 2. That gives me negative 8. Yeah, so, well, the scale's a bit large there, but we can see, yeah, it's roughly about -8. Starts and finishes. We've got x to the 4, x cubed, x squared, x to the power of 1, gives us x to the power of 10, which again would start up here, finish up here, so that's fine. The x-intercepts would be 1, there it is. It's a quartic root or a fourth root, so you can see it's not like a parabola, it's flatter at the base, steeper at the sides, just like y equals x to the power of 4 would be. X plus 1 cubed, so it'll inflect at -1, and there it is, doing the cubic. At -2, it will look more like a parabola because it's a double root, and so there we have that one. And at +2, it's just going to cut it like a straight line because it's to the power of 1. Okay.
In this case,